Welcome students. In this class we are going to see about the that is the groundwater exploration techniques, and also we will be seeing about the hydrology cycle. Right, first we will see about the hydrology cycle. We know what is a water table. Water table is mainly due to the precipitation, formation of rain and snow. Right, it is mainly made up of precipitation, rain and snow. Okay, so the discharge of groundwater will be mainly from the flow in lakes, reservoirs, rivers, ocean and springs. Artificial is the pumpage from well. Okay, so already we have seen the properties why we are using. Now we go for hydrology. Before going in for the hydrology cycle, we will see what is a hydrology. Hydrology is a science which deals with the occurrence, distribution and movement of water on the earth, including that in the atmosphere and below the surface of the earth. Not only in the atmospheric pressure and below the surface, that is groundwater, we call it as a hydrology. The hydrology is the science which deals with the occurrence, distribution and movement of water on the earth, including that in the atmosphere and below the surface of the earth. So, how the water are the form of water available in the atmosphere. In the atmosphere, the water is available in the form of vapor. Sometimes we feel chillness, not that moisture content. Sometimes we feel dry. That is all in the atmosphere. The second one, it is in the surface, which forms as the water, snow or ice. It is found in the form of water, snow or ice. Below the ground surface, groundwater occupying all the voids within a geological stratum. Okay. So you can see here, this is a hydrological cycle. Okay. So this is a precipitation or the rain that is coming out due to the condensation of the clouds. It forms into it. Some water it will infiltration into the ground. The snow also formed on the surface also infiltrates. That is, it percolates into the ground. So this is a water table. Okay, this is the zone. It will some will go for runoff to a stream or a lake or a river. Right? Some will be evaporated from the ground surface. This will be transpirated, right? Even evaporated from the lake or ocean or river surface. Okay, so this is the hydrological surface. This is the evaporation and transpiration. The water will be taken and it will form the cloud and it will again come as a rain and snowfall. This is a cycle, hydrology cycle. So the precipitation of rain or snow will be there, which will be going into the lake, river or ocean, where the evaporation and from the trees transpiration will take place. This water vapor will again condense, it forms into a precipitation. This cycle we call it as a hydrological cycle. So the hydrological cycle, precipitation either in the form of rain or snow will be equivalent to evaporation and runoff, which we call it as a evapotranspiration and the runoff. Okay. So, in the presence of transfer of moisture from the atmosphere to the earth in the formation of precipitation, conveyance of water by streams, rivers, oceans, lakes, etc., evaporation of water back to the atmosphere. You can see here. So, the precipitation to the land. Okay. So, this is the rainwater that is here. You can see here that is the white color clouds from the town. Rainwater is there from the mountain. It is a runoff. Right. We call this as a runoff. Right? So, surface runoff, we call it on the surface. It is a runoff, that is a formation of streams. That from the mountain streams all comes now, that is formation of runoff. Right? So, this is a water table. So, in the this will act like this, and some things will get infiltrated. Right? Some water will get infiltrated. That is going to the groundwater level. Okay? So, then some water will be there. And this will be absorbed by the trees, and from these trees the water that is evaporate, we call it as a transpiration. Other evaporation from precipitation, from here some water will evaporate from the surface, that is either a lake or a stream or a ocean, water will evaporate. Everything that will go and form the clouds. Right? Evaporation from the land, evaporation from the soil, transpiration from the vegetation, evaporation from reservoir, everything from ocean, everything it will go and it will form the clouds. Again these clouds will go and give the rain, right? Rain or in the form of snow or rain. Okay. So this is the infiltration. This is the groundwater flow, which will also go and join in the ocean. This is a salt water. From the ocean, there will be a backwater that we call it as a salt water intrusion. It will also be there, and precipitates for rainwater will come to the ocean, which has a which also be changed into a salt water. Okay, so this is the hydrological cycle. So again, I have given some 2 or 3 diagrams. So whichever you feel it is easy, you can take it, right? So from that it will form as a precipitation, it infiltrates into the ground, it goes out as evapotranspiration. Evaporation combines together with the transpiration, we call it as the evapotranspiration. Transpiration is from the trees and evaporation is from all the land and the water surface, and the land surface we call it as evaporation. So it will go and it forms the cloud, and the cycle will follow. Lakes, stream, water, evaporates, transpirates, then forms the clouds, then again it will go. Some water will go into infiltrates into the ground. So you can see here, it is easy for you to understand. So what is evaporation and transpiration? So surface evaporation, water surface evaporation from the river surface, from ocean, from lakes, we call it as a water surface evaporation. Transpiration is from the trees. Atmospheric evaporation is from the rain when it is coming to it. If it is a very hot one, from there itself it will evaporate. And the precipitation is liquid precipitation, rainfall. Frozen precipitation is snow, hail, sleet, freezing rain. And runoff is the surface runoff. That is, if it is rain is coming here, some water will go like this, right? That is surface runoff. Some water will go like this, that is subsurface runoff. Or the groundwater, that is, it will reaches the ground, and this may be the water table. From the ground level, it reaches the stream or lakes. We call it as the groundwater or the base flow. So this is a hydrologic cycle. I told you already, evapotranspiration is a term used to sum the evaporation from the ground and the water bodies, and the transpiration from the earth's land surface to atmosphere. Therefore, evaporation occurs for the movement of water to the air from the sources such as soil, canopy, interception, and all water bodies. Transpiration occurs from the water within a plant and the subsequent loss of water as a vapor through stomata or in its leaf. Evapotranspiration is an important part in the hydrological cycle. So evaporation plus transpiration. Evaporation is maybe from the land surface or from the water, lake, any bodies. We call it as evaporation. From this we call it as a transpiration. Combined together we call it as a evapotranspiration. Okay. So the next one, it is evapotranspiration. Again I am telling you, it denotes the quantity of water transpired by plants during their growth or retained in the plant tissue plus moisture evaporated from the surface of the soil in the vegetation. Factors affecting the evapotranspiration is the weather, crop characteristics, management and environmental conditions. Grass gives you the transpiration very little, whereas we give very big plants, very big trees will give you the more evaporation of water. So it depends upon the characteristics, weather, management and environmental conditions. So these are some of the precipitation method in any type of water that forms the earth atmosphere, then drops onto the surface of the earth. So this is a rain, right? This is a rain, this is a snowfall or a rain that is coming there. It forms the precipitation, something, the water level that is coming to the ground. Water vapor in the atmosphere is visible, and we can see if there is a black color water vapor that is formed in the clouds, we will see that there is a there will be a form, that is rain may be coming because the clouds are formed, and clouds eventually get too full of water vapor and the precipitation turns into a liquid or snow. It may be a snowfall or it will be a liquid fall which happens as a rain. So water vapor and droplets of water suspended in the air builds up as a earth atmosphere. Some water atmosphere, there itself the water will be stagnated, the moisture will be taken which forms the water droplets. Okay, you can see the water droplets in the morning as a dew and other things. So condensation, nuclei attracting water vapor collects with the other materials such as dust and clouds, precipitates, condense and formed around these tiny pieces of material. You can see here, like these are small types of dews that will be available in the ground surface of the trees. We can see it is due to the condensation of the water vapor. It reacts with the dirt and other moisture small particles. It acts as and forms as a slow force, that is a water droplet in the ground. We can see it as a water that is there. And the other type of precipitation is the snow and rain. All of us know what is the snow, what is the rain. It eventually evaporates and rises back to the atmosphere as a gas, which is the main formation of the clouds again. So mostly the people rely on this precipitation of water for the drinking and other purpose. So in the clouds it turns back into the liquid and water, it falls to the earth ground, which the peoples are mainly relying, right? Okay. So all forms of water that reaches earth's surface is known as the precipitation. It is expressed in terms of depth to which rainfall water would stand on an area if all the rain were collected on it. In case of snowfall, water equivalent depth of water is considered as depth of precipitation. Rain gauges are used for measurement of precipitation. So in India, IMD or Indian Meteorological Department is the main thing who will tell how much water will be precipitated. They will have a rainwater data for several years, right? And what are the factors that affects the precipitation? Are the lifting of air mass, cooling of warm air, and the condensation process. And there are four types of precipitation occurs. Cyclonic precipitation, which is by lifting the air mass, and due to the pressure difference, precipitation may occur. Convective precipitation is caused due to the upward movement of air in a warmer, and then when this warmer air, when it is moving up, when it is condensation takes place, it will form and it will comes as a precipitation. It is mainly in the tropical area. Orographic precipitation is responsible for heavy rains in case of the mountains and other things, which strikes some natural topographic barriers such as mountains. That is, when the water vapor strikes very high mountains and other things, it will move up and it high pressure and it forms a rainy area. Then it rains. Most of the rains are formed in the hilly regions, mainly because of this orographic precipitation. And precipitation due to turbulent ascent. Turbulent ascent due to the that is cyclonic effect of the vapor that is rises out and it forms a cloudy layer and it forms as a precipitation. So some of the forms of precipitation you can see, that is a storm and rain. This is a small drizzling. Here you can see the rain and other things. This is a hail. Okay, you can see now different parts. This is snowfalls you can see here. Now we will see about the different forms of precipitation. These are, we call it as a hail. Rainwater is only the formation of water that is formed. Other types are formed in the case of snow. Rain, the liquid deposit from the atmosphere to the surface with a diameter greater than 0.5 mm at drizzle. Maximum size is 5 to 7 mm, too large to remain suspended. Beyond this size, the intermolecular cohesive forces becomes too weak to be held in the mass of water together at a single drop. The next one, it is a freezing point. So when the water droplets reaches the ground as a snow, then we call it as a freezing point. When it reaches the freezers and it will form as a snow point. That we call it as a snow. The next one, it is a sleet, the ice pellet. The diameter is greater than 5 mm and the temperature will be just the freezing temperature or less than 0 degree temperature. It freezes and it forms as a ice pellets. Pellets are small pieces of ice. And the next one, it is a snowfall. Snowfall, you can see it is a northern hemisphere and the southern hemisphere. Mostly it will have a snowfall in the winter region. It is having a mid-high altitudes. It develops water vapor deposition. 6-sided hexagonal. Actually, take it as a very small microscope and we see a snow particles. It will be like a hexagonal shape. And this is mostly a unique formation of this one. Last one, it is a hail. Hail is that in the case of summer, you will have some snow rainfall, right? That we call it as the hail, where the snow will be more than 5 mm thickness. Okay, so this is the formation of hail, mainly due to the cyclonic activity. These hails are formed where the very hot sun is there. The warm dust air, the warm air moves out upward and forms as a hail, and it reaches the ground as a snow, right? So the next one is the precipitation. I told you precipitation is the flow from the water into that is it is precipitation. It is mainly form of rain and snow, right? So now how much water is going to infiltrate into the ground? That is the formation of the groundwater. How groundwater, the aquifers, everything depends on the soil properties. The other thing is it is depends upon the infiltration properties. So what is infiltration? The process of entering rainwater into the soil strata of the earth is called as the infiltration. The infiltrated water first meets the soil moisture deficiency in any and excess water moves vertically downwards to reach the water table. This vertical movement we call it as the percolation, or we call the water percolates into the ground. It is an infiltration. We call the water moves vertically to reach the groundwater table. The process we call it as the percolation. So the infiltration depends, that is the process of infiltration by which the water reaches the water table, we call it percolation. The infiltration capacity of the soil depends upon the maximum rate in which they are capable of absorbing water, and it is determined by F, right? Infiltration capacity is defined as the maximum rate at which it is capable of absorbing water, and it is determined by the letter H. The infiltration of the capacity F, if infiltration is greater than or equivalent to F, then it depends upon the soil capacity. If I is less than F, it depends, FA is equal to I, it depends upon the rainfall intensity, where FA is equal to actual rainfall capacity, and I is the rate of rainfall and F is the infiltration capacity. So FA is the actual infiltration capacity, F is the infiltration, what is the infiltration that happened, and I is the rate of rainfall. So if the rate of rainfall is greater than or equivalent to F, then we tell it is that it depends upon the soil capacity. If I is less than F and alpha is equal to 1, it depends upon the rainfall intensity. Okay, so the next one we will see is the rate at which the soil is able to absorb rainfall or irrigation. It is measured by millimeter per hour or centimeter per hour. This much centimeter, this much millimeter per hour we will see, right? Okay, there is some problem, so it is moving here and there. Maximum rate of water absorption is called as the infiltration capacity. Maximum capacity of water that is absorbed by the soil, we call it as the field capacity. The rate at which the soil is able to absorb rainfall, that we call it as the infiltrometer, is used to measure. And when I is the rainfall is greater than F, then the runoff occurs. So it mainly will deal about the two terms, that is we call it as the hydraulic conductivity. Ability of the fluid to flow through the porous medium, we call it as the hydraulic conductivity. Okay, and it is determined by the size and shape of the pore spaces in the medium and viscosity of the fluid. It is expressed as the volume of fluid that will move in unit time under a unit hydraulic gradient through which the unit area measured perpendicular to the direction of the flow. So if they tell us hydraulic conductivity is the ability of the fluid to flow through a porous medium. It is determined by the size and shape of the pore spaces in the medium and the viscosity of the fluid. It is expressed as the volume of fluid that will move in unit time under a unit hydraulic gradient through a unit area measured perpendicular to the unit direction. Okay, so the next one we will be seeing is the factors affecting this infiltration capacity. The first one, it is the scope of the land. The slope of the land, the steeper the slope, the infiltration will be less. Okay, so if the water is steeper the load, the rainfall, the water will go like this. Okay, the water will fall like this. It can fall, right? It will easily fall like this. So the infiltration into the ground will be very minimum. That is what it is there. So the steeper the ground, the infiltration will be the steeper the slope, the infiltration will be less. The next one we will see degree of saturation. So the degree of saturation, more the saturation, so the more the saturated the loose earth materials are less the infiltration. So if there is a clay content is there, the infiltration will be very less compared to the sand. Okay. So next one, it is a porosity. The porosity is the percentage of open space, as we know. If the porosity is more, then the infiltration will be more. If I am going to take a clay block and a sponge, the infiltration through this will be very high. Rather than it won't get infiltrated here. Right? It will not infiltrate it. So the greater the porosity, greater is the amount of infiltration. So here you can see. So if the packing of soil grains, the fourth one, it is the packing of soil grains. If the packing of soil grains are very loose, then the infiltration will be more. If it is very tightly packed, then the infiltration will be very less. Depending upon the packing of the soil particles or soil grains, we can know the infiltration things. And next one is the compaction. If the compaction is more or the clay surface soil is compacted, then the impact of the raindrops will be very, that is, it cannot enter into the soil layer. So which reduce infiltration, the effect is negligible in the sandy soils. Okay. So the next one, it is the surface cover condition, that is the vegetation. Grasses, trees and other plant types capture falling precipitation or leaf branches, keeping that water being absorbed in the earth and the more time to reach the ground. So more the vegetation, less the infiltration capacity. Because what will happen is capture the falling precipitation and keep the water from being absorbed into the water and takes time to reach us to the ground. It will take the water and it will not allow the water to reach us the ground on time. So the infiltration will be very less. And the next one, the land use. So roads, parking plots and buildings create surfaces that are not longer permeable. This infiltration is less. Okay, the next one, it is a temperature. So at high temperature, viscosity decreases and the infiltration increases. So the temperature, viscosity decreases and the infiltration increases. So the summer, the infiltration will be more. In winter, the infiltration will be less because the pores will be almost filled with the water. So the winter season, the infiltration will be less. What are the other factors that affects the infiltration of entrapped air and pores? So the entrapped air can greatly affect the hydraulic conductivity, by which the this infiltration will be less. Quality of water. If the quality of water is having more turbidity or it is having colloidal matter into it, or it has colloidal water, has some dirt and other dirts in it, then the quality of water will be having some impurities. It cannot be infiltrated into the sand. The next one, it is a freezing. Freezing in winter may lock the pores. By the water get freezes into it, so the discontinuity of the pores will be there, by which it will reduce the this infiltration. And next one, it is annual seasonal changes. That is, when the rainfall is more, the infiltration will be less. When the rainfall is less, the infiltration will be more. Like that, these are the factors that affect the infiltration. So in this class, we have seen about what is a hydrological cycle, and we saw what is the precipitation, and we saw what are the precipitation is mainly due to rain and snow, and what are the different forms of precipitation also we saw, and we saw what is the infiltration, and we saw what is the infiltration capacity, and we saw what are the factors that affects the infiltration. So the next class we will see about the last topic of the unit 4. Thank you.